Hey guys, today we're taking a look at positive rational exponents. Now, it sounds a little bit complicated, but it's really pretty straightforward, and I think you'll catch on really quickly. This rational exponents theorem simply says for any non-negative x is our base, and positive integers m and n, then x to the m over n power is the same thing as the nth root of x raised to the mth power. Now, here's another way to think about this. Here is our base x raised to this m power. This is going to represent the power or the exponent that we're raising x to. And the denominator here, our n, is going to represent the root that we're going to be taking. So we're doing both a power and a root here. So here's an example. This 4 to the 3/2 is the equivalent of the square root of 4 raised to the third power. So notice 3 is our numerator of this fraction, and that's the power that we're taking. 2 is the denominator, and it's the root that we're taking. Now, you could switch those around, because remember, multiplication is commutative, so I can multiply it by the 1/2 power first, and then the 3, or the 3 and then the 1/2 power. So this would be 4 cubed, taking the square root of that. All right, now let's take a look at some more examples here, and I think you'll catch on really quickly. We're going to simplify these, and then we're done. We're going to check our answers using our calculator. So 16 to the 3/2 power is the same thing as saying 16 to the 1/2 power to the third power. Or in other words, the square root of 16, which is 4 to the third power. Now 4 to the third power, it results in 64. All right, B says 27 to the 2/3. Now this is the equivalent of saying 27 to the 1/3 power. Then we're going to take that result and square it. So the 1/3 power, remember, is the cube root of 27. The cube root of 27 is 3. So 3 squared results in 9. All right, next we have a fraction that's being raised to the power of 4/3. So that means both the numerator and the denominator need to be raised to the 4/3. So let's just take a look at this. We have 27 over 64 to the 1/3, and then we're going to take that and raise the results of that to the 4th power. So the cube root of 27, the cube root of 4 simplifies to 3/4, and we're going to take that 3/4 and raise it to the 4th power. Now 3 to the 4th power is 81, and 4 to the 4th power is 256. All right. As you can see here, it comes in really handy knowing your powers tables. So if you haven't committed that to memory yet, maybe you want to do that this unit. So 8 to the 2/3, I'm going to rewrite that as 8 to the 1/3 squared, or I can do my powers first as well. So maybe this time we're going to do 8 squared, and then we're going to take the 1/3 power of that. So 8 squared is 64. 64 to the 1/3, which remembers I'm going to take the cube root of 64, and the cube root of 64 is 4. All right, 32 to the 3/2, we're going to take 32, and let's take the square root of 32 first, and then raise that to the 3rd power. Now, the square root of 32 is not a nice number, so we're going to do this one just on our calculator. Now 125 over 8 to the 2/3, so this results in a 125 over 8. And we're going to take the cube root of that first, and then we will square that. So that is 5 over 2 squared, and that results in 25 over 4. So let's pause and let's go to our graphing calculator here and see how we can enter some of these numbers in using our graphing calculator. So let's just check this first one. We'll enter 16, and we're going to have our little up arrow, and then in parentheses 3 divided by 2. We'll close our parentheses and we'll press enter, and we get 64, which is the same result we got by hand. All right, let's check a couple more. We have 27, and let's raise that to the 2/3 power now. So we'll do 2 divided by 3, and you see our calculator can handle that just fine. Our result is 9. So let's try this 32 to the 3/2. We know that 32 raise. Now we'll do 3 divided by 2 inside our power, and we can see that the result there is 181.01. All right, so this is 181.01. Let's scroll down and check out example 3 now. It says to solve these equations. So whenever we're looking to solve, we want to get x or whatever our variable is by itself. by using inverse operations. So here we see we have the square root of x is equal to 5. Well, in order to undo that power of 1/2, we need to get a power on x to be 1. So we're going to multiply those powers, which means I need to take a power of a power. And so if I take this 1/2 and raise it to the second power, I have to take 5 and raise it to the second power as well. So now these powers will go to 1, so I'll have x by itself, and 5 squared is 25. So x is 25. Our next example, we're going to do the same thing, and I'm just, again, going to take that power, which is 3/4, and I'm going to raise it to the reciprocal of that power, which is 4/3. That way, when I take a power of powers, this result will be 12 over 12, which reduces to 1, and this will be x to the first power, or just x. Now, let's go back up to this first line here. What I do to one side, I have to also do to the other side. So I need to take 27 and raise it to the 4/3 power, which means I'm taking the cube root of 27, so that's 27 to the 1/3, and then that result to the 4th power, and the cube root of 27 is 3, so 3 to the 4th, which is 81. So x is equal to 81 for letter B. All right, in letter C, we are going to start off by dividing our 2 over to the other side so that we get our y variable by itself. Now I have y to the 4/3 is equal to 625. All right, I need to get y by itself, so I'm going to raise both sides to the reciprocal power of 4/3, which is 3/4. So 625 to the 3/4 means I'm going to take the 4th root of 625 and then cube that. So y now is equal to, the 4th root of 625 is 5. 5 cubed is 125. All right, let's try example 4 here. It says to try these on your own. We'll check them in class, but I'm going to run you through a few examples here. You have v to the 5/4. In order to undo that power of 5/4, we're going to take it to the 4/5. So that means 32 needs to be raised to the 4/5 as well, which is 32 to the 1/5 power, which is the 5th root of 32, and that's 2. And then we're going to raise that to the 4th power. So 2 to the 4 is equal to 16. Next, we have x to the 2/3 plus 2. We're going to start by subtracting that 2 over. I have x to the 2/3 is now equal to 25. Raise that to the 3/2, which means I need to do the same thing with my 25. So I get x is equal to, this is the square root of 25, which is 5, cubed, and that results in 125. All right. Finally here for our examples for today, let's simplify these using what we know about our rational exponents. So we have 1/3 power of this product, and so that 1/3 needs to go both to the 125 and to the x to the 6. So that's the cube root of 125 and x to the 6 cube rooted. So to simplify this, we're going to take the cube root of 125, which is 5, and then x to the 6 to the 1/3. Now remember, we need to multiply these. So 6 times 1/3 is 6 over 3, which simplifies to 2. So it's 5x squared. All right, and final example here for B, we're going to see that we have this power of this quotient and this product inside. So we need to distribute this 3/2 power to all of these terms. So I end up with 49 to the 3/2, t to the 4th to the 3/2, all divided by 9 to the 3/2, s to the 10th to the 3/2, and t squared to the 3/2. Now let's go through and simplify all of our exponents. So we're really taking the square root here of 49, which is 7, and 7 cubed is 343. Now t to the 4th to the 3/2 is 4 times 3/2, so that's t to the 12/2. And now we have 9 to the 3/2, so it's the square root of 9 cubed, which is 27. And then s to the 10 times 3/2, so that's 30/2. And t squared to the 3/2, so that's 2 times 3, which is 6/2. And now let's simplify one final time. That gives us 343 t to the 6 divided by 27 s to the 15th t to the 3rd. And I guess there's actually one more final step we can take in simplifying, because we have t to the 6 on top and t cubed on the bottom. So our final should be 343 t cubed in the numerator divided by 27 s to the 15th power in the denominator. And there you have it.